So the problem we're going to be looking at tonight is a 7-part question, and we'll see what we can get through. In the 330 class, we only got through A, B, C, D. There was a lot of questions, and that's okay. So just be prepared to, ask questions and don't sit back quietly. And if you have stuff that you're not sure about, we'll get a conversation going to figure it out. But there's some tricky parts to this. So we're going to take our time and we're in no rush and we will see what we get through. So that said, here we are. So let's take a second and I'll just give you about 60 seconds to just read and get yourself acclimated to the problem. Okay, go ahead and read. Okay, so there's a lot of things happening here. First one I see is that we're talking about a particle moving. So it sounds familiar. It's moving left and right across the x-axis. So that's no big deal. And then we start to say, all right, what did they give me? So I have things about velocity in a box. All things involving the velocity of my particle are in the box. We have this graph for F. We don't entirely know what that is yet, but we have a graph for it. And the other thing I see is some things in the paragraph. They give me some selected values of acceleration. So obviously that's going to be needed somewhere. But if I need a specific acceleration, it's probably in the paragraph. So we got velocity in the box. We have a graph for F. And now let's see what they're going to be up to. What are they asking? So this was last year when it was online and the test format was entirely different. So you're seeing here that it says 25 minutes. So that was last year's special format. So you're not going to have a 25-minute question this year. But that said, all the stuff that's on here is very good stuff that you need to know. So let's see. All right, here we are. So we're looking at right now, just A and B. Let's look at, that didn't help any. You're looking at only A and B. So I want you to just copy the questions down real quick. Copy down A, copy down B, and then just pause and I'm going to flip the screen back so that you can see the actual problem. So copy A and copy B. So in part A, d dt means to take the derivative of whatever you see. And then this notation down here means also plug in 1. That means find the derivative and plug in 1. Second one says you're using a trapezoidal sum with 3 subintervals to approximate the value of this. Okay. So I have them copied here for you. And we're going to go back now to the main page. Does anybody have any questions? Okay, so these are two things being multiplied together. So if they're being multiplied together, we should probably do, what rule would you say for that, guys? The derivative of two things multiplied together requires what rule?
Chain rule.
What rule?
Product.
Product rule. So we want to do a product rule. And what happens when I need to take the derivative of v? What's that going to give me?
The regular, like the original form, the position.
The derivative, not integral.
Oh, the acceleration.
Okay, cool. Acceleration. And then you're going to say to yourself, well, how do I figure that out? And then take a note. It's in the paragraph. What are we plugging into this? We're plugging in 1. So it works out. The information you need is available in the paragraph. Second one, you shouldn't have any trouble with trapezoidal estimate. Just write out the math and you'll be okay. Okay, it is 7:38. You have until 7:45-ish. And then we will go over these. Ready, go.
Mr. Baker, should we do the math on the second question?
Nope, just leave it as the multiplication.
Okay.
All right, let's talk. First one, if we are going to find this derivative, we need to do a product rule. So our product rule should go first derive the second. So first, up to you how you write derive the second. You want to go V prime, you're good there. You want to call it A, also good there. V prime and A mean the same thing, so whatever. First derive the second plus the second derive the first. Any questions on that derivative? Okay, and we're putting 1 into all of these. So what's f of 1? We got a graph for that. F of 1 is 1. What is a of 1? Remember we said earlier, accelerations were in the opening paragraph. A of 1, -10, plus v of 1, that's in the box. V of 1, -29. And somebody explain to us, how do we find f prime of 1, please?
Getting the slope from the graph.
And what is that slope?
2.
Perfect. If you like, you can leave this as your answer, or we can do a little more math and say that it's -10 minus 58, which is -68, up to you. But you should be good there either way. Okay. Any questions on the first one? Okay, and the second one is nothing more than just setting up the math and leaving it there. So make sure you write the integral. You say it's approximately equal to, and we're going to add up the bases. That's the y values. So 0 plus 55. We're going to cut them in half, and we're going to times it by the height of 0.3. Plus, add up the bases, cut it in half, times the height, 0.7. We're going to do it one more time. We're going to add up the bases. We're going to cut it in half. We're going to times it by the height. And that's it. You're done. Any questions on B? All right, so we got A and B in the book. Let's see what we got for C and D. All right, take a second. Part D, we did one of those yesterday, so D is what it is. Take a second now and let's have you read part C, because this is quite a question. Or first off, how about just copy it down? Let's go with that. They're telling us from -6 to 5, f of t dt is equal to 7. And we are looking for -6 to -2, f of t dt. Show the work that leads to our answer. All right, we are being given -6 to 5, and we're looking for -6 to -2. Okay, what are our initial comments, thoughts, ideas? What's the plan? What are they asking? What do we got to do?
It meant that the area from 5 to -6, 7. So what's the area from -2 to -6, I guess?
Yes, but what's the problem with that -2 to -6?
It only goes to 5.
Only goes to 5 on the right. It only goes to -2 on the left. I'm asking from -2 to 6. We can't even see that. That's over here somewhere in space. I don't even have a graph for that. So what's the plan? How do we do this, guys? Think, think, think. What did they give me and how can I use it? What did they give us and how can we use it?
Take the if we find out what the initial one was, we can then subtract. I don't know how to phrase this, but if we know that from 5 to -6 is equal to 7, then we can figure out what the bounds of -2 to 5 were and then subtract it from 7.
Perfect. Let me translate what he just said, but everything he just said was perfect. All right, so let's think of this as a number line. It's the easiest way to wrap your head around it. Here's 0. All right, what do we know about my number line? What do we know about my story? They tell us point blank that from -6 to 5, this area is 7. And then it asks us to find -6 to -2. That's the answer to the question. However, we don't have a graph for that at all. We do, however, have a graph for -2 to 5. So what Preston said is, well, we can find this. We can find the red stuff. The question asks us to find the blue stuff. So if I went and found the area of the stuff I could see, and this is the piece that I want, would it make sense to say that the answer to the question is 7 minus whatever that is? Does that make sense, guys?
Yeah.
Okay, so let's go back now and take a look at the graph. We are going to try to find the area from -2 to 5 and then subtract it from 7 to give me the blue. Now, when it comes time to find area, let's make sure we're finding the right spots. Follow, can you guys see the cursor moving?
Yes.
We're looking for this area right here, that little triangle. We're looking for these 2 triangles underneath. We're looking for this little sliver of a piece right here that makes a triangle with this thing up here. And then we're looking for this curved area under here. What can you tell me about this curved area? This is a quarter circle. So there's a lot of logic required here. It is 7:53. You've got about 10 minutes or so, if not even a little more, to tackle part C and part D, and then I will be calling on you guys for conversation. Ready, go. All right, I'm back. Sorry, Caleb, I didn't see that message. I just sat back down. I stepped away for a minute. All right. So we are looking for all of these areas, and then the plan is going to be to subtract it from 7. So, Josh, you there? How about Grace?
I'm here.
All right, tell me the first area. What do we got?
You're going from -2 to -1.
Yep.
So it's the triangle. So it's just going to be 1/2, 1, and then the height is also 1. So it's just going to become 1/2.
Got it. All right, so that takes care of the first area. So we're going to track these areas and see what we get to. So we got the first one is 1/2. All right, the next one, we want to find the area underneath. Angie, you there? Emily, how about that? You there?
Yeah,
All right, what do we got for underneath? What's going on here?
I got 1/2, and then for that first part, and then
Oh, you did 2 different areas, you're saying?
oh yeah,
Okay, that's fine. That's fine. Doesn't matter how you did it. Okay, so the first one's 1/2 and it's negative, correct?
yeah.
Okay, next one. What are you doing over here?
I wasn't sure about that one.
Yeah, fair enough. All right, so here's how we find this, guys. It's messy because you're like, well, what is that? It's not on anything. So a little bit ago, didn't you guys tell me the slope of this line? Somebody did. The slope of this line is 2, right? So if the slope has a rise of 2 and a run of 1, if we want, we can cut that in half. So remember, it's rise 2, run 1. At the end of the day, the slope's got to be 2. Another way of saying that is instead of a rise of 2, it's a rise of 1 and then a run of 1/2. That is still a slope of 2. If I go up 1 over 1/2, that's still a slope of 2. So even though it's kind of messy, we can still prove to ourselves that this right here is at 0.5. That's at 1/2. So Emily, with that in mind now, what are we going to do to find the second area?
So
So I'm saying the dimensions here are, this is 1, obviously, and then this is 1/2 going that way.
is it a quarter?
So it would be 1/2 times 1, which is 1/2, and then we cut it in half. I agree. It's a quarter. And since it's underneath, we're going to call it
Yeah.
negative. Okay, got it. All right, next. Now we need to go back up to the top. And now I think we can make this all one big triangle. Or another way of doing this might be to do what? What could we do with this? Emily, keep going because you just talked about this. So what are the dimensions of this triangle above?
So it's 3 up, and then
This little triangle right here.
that's a quarter as well.
So yeah, exactly. So it's the same exact thing. That's why I called you and you talk about it again. So far, guys, all of this cancels out, right? You can say positive, negative, negative, positive. Okay, that's all gone. Okay, now we're over to this thing. And what is this shape? From 1 to 2, and then up in the air, what shape are we talking about? Syed, what do you think?
Trapezoid.
The trapezoid. So how do we find the area of a trapezoid? We add up the bases, cut it in half times the height. So what are the bases, Syed?
1 and 3.
Gives me 4, cut it in half
2.
times the height.
It's 1.
Hold on, let's do this again. Add up the bases
Yes, and that's 4.
with you, cut it in half
2.
times the height.
Yes, that's 1.
So yeah, what's the final answer though?
It's 4. It's 2. So
Add up the bases, 1 and 3, right?
yes.
All right,
4.
that's 4. Cut it in half. That's 2. Keep
And
that 2 because when I times it by the height, is that changing anything?
No.
No. All right, so we're going with 2. All right, so now we've got that. So now I'm just gonna say cancel those, because those are all gonna wash. All right, now we need to find the area. Here comes the main event, the area of this thing over there. So who feels brave enough to talk to me about the quarter circle? Somebody.
Doesn't it look like a trapezoid still?
Yeah, but it's rounded, so we're no good there. It can't be round. It can't be rounded. So let me turn this off for a second and give you a better visual. So this thing is from 2 to 5. So if we're going from 2 to 5, and then I'm just going to draw this up. It goes up to 3. This is not quite drawn to scale. I'm just highlighting the part we care about. And it does this. All right. I want to find this area right here. I want the red area. And it says in the directions, and I also told you that the curved part is a quarter circle. So what's the plan here, guys?
A Riemann sum for this?
No Riemann sums.
Wait, aren't we given the area from 2 to 5?
No.
No.
Keyword, it's a quarter circle.
Oh, so
Like maybe the circumference formula?
I don't think the circumference is going to do anything, but what's the other formula for a circle that might help us?
Area.
All right, now, before we do any of that, let's do the following. Let's make a box out of this. This is an important skill. This is on the SATs too. Quarter circle area. All right, so I made a box out of this. And hopefully everybody's on board that the area of this box, everybody good with it being 9, 3 by 3, right? The area of this whole box is 9. Now, would it make sense to say that the area that I want, the red area, is going to be 9 minus the blue? Just geometrically, does that make sense?
Yes.
Yes.
Okay, now, so the area we're looking for this red, that red area is 9 minus, we got to figure out the blue. Here's how we figure out the blue. They tell you it's a quarter circle. That must mean it belongs to a circle. So to me, I'm going to draw the circle. And now I'm looking at a circle. I want to get rid of a quarter of it. How do I find the area of the whole circle?
Pi r squared.
Pi r squared. What's r?
Radius.
Yeah, I know that. What's the number?
That would be 3.
There we go. That's what I wanted to see. So the radius is 3. So what's the area of this circle, Preston?
9 pi.
Yep, good. So that's 9 pi. That's the whole circle. Preston, I only care about a quarter of it. What's the area of the quarter circle?
Divided by 4.
9 pi over 4. The area of the red is 9 minus 9 pi over 4. That's my last piece. Do we have any questions? These are all the areas for, I told you there's a lot to this problem. These are all the areas for this graph. Now, let's not lose track of what we're doing. We still got something else to consider. And that is, what was the actual plan for this problem? We're trying to find this, which we just found this. We just figured out now. We got all the areas for this red. How do I get to the actual answer? The actual answer is going to be what, guys?
subtract from 7.
7 minus whatever we just figured out. What did we just figure out? I don't know. Let's figure out what we just figured out. What we just figured out was 2 plus 9 minus 9 pi over 4. Up to you how you write this. Here's how I'm going to write it. And then here's how I'm going to rate my answer. That right there is what -6 to -2 f of t dt is equal to. Because remember, once you're down to math, you don't have to simplify it. We could make this cleaner, but they'll give you credit for that. Now, if it helps you sleep any better, I consider that like a 9 or a 10 out of 10 level difficulty. But if you can wrap your head around it, that's certainly very good and it'll help you. I've seen more than one quarter circle on AP exams in previous years, or I've seen like, not like every year, but like there's been more than one problem over the years that has involved finding the area under a quarter circle.
Can you zoom out a little bit that I can take a picture of? Thank you.
Mhm.
Mr. Baker, was it 25 minutes for the whole test?
Yeah, it was 25 minutes for this problem. A, B, C, D, E, F, G.
That's a lot.
So, yeah, let's see. When you look at it, part A, 2 minutes. Part B, 1 minute. Part C, a lot of minutes. Part D coming up, I think we're going to do part D in 2 or 3 minutes. So, and again, I mean, obviously it's great if we get 100%. But again, if you're getting even 70, 80% of these, you're going to fly through the AP exam. You do not have to ace this. You just want to get everything that you can. So take a look for part D. Time-wise, we should zip right through part D. You recognize its integration. You've done a couple of these now. So I'm going to take the 2 out front, 3 to 5, f prime of t, dt. I'm going to split these up because it makes it easier. And in under 30 seconds, we're ready to go. So now we integrate. And this is 2. What do you get if you integrate f prime? You get f. So this is going to be f of t from 5 to 3 plus 4t from 5 to 3. All we do now is shove in some bounds, see what we get. So this would be 2 times f of 5 minus f of 3 plus 20 minus 12 is 8. We need to figure out f of 5 minus f of 3. F of 5 minus f of 3. So we have a graph for f. So now we want to go check out the graph and see what we get. So what do we know about f? We're looking for f of 5. Easy enough. 0. So that's 2 times 0 minus something plus 8. Okay, what's the other one we need? F of 3. You got to look up f of 3 and you go, ooh, don't know what that is. So your options at that point are give up or know that there's a way to figure this out. And odds are good if it's something that looks really bizarre. Read the opening paragraphs. They probably just tell it to you. And if you come on down here, it tells you out of nowhere, oh, and by the way, the coordinate for 3 comma whatever is 3 comma 3 minus radical 5. So f of 3 corresponds to 3 minus radical 5. So my point was, try not to give up. If something seems really weird, and you have no idea how to find it, reread the problem. There's a 50-50 chance the information you need is just sitting there. And you can rate your answer just like this and stop. Again, we could clean it up and make it nicer. But they'll take that, so there's no point worrying about it. Questions on anything we've done tonight? Okay, tomorrow, make sure you're here. We got to spend a lot of time on part E. That's absolute extrema, and it's been many, many, many months since we've talked about it, and it's all over the AP exam free response. So we've got a lot of talking to do about part E tomorrow night, and then F and G shouldn't be too hard. But I would venture to guess we're going to spend at least 20, 30 minutes on part E alone, just talking about how to do it and going over it and stuff like that. And then over the weekend, I already mentioned, I'm going to be giving you guys a lesson to watch on a topic that's important. And then next week, we'll be spending time on that topic. Okay. Any questions, guys? All right, give me 1 second. Bennett, I'm all good here. You can turn it off. I'm just copying some attendance down and we will be out of here. All right, guys. Looks good. Good job. See you tomorrow.
Thank you.
Thank you, Mr. Baker.
You got it. See ya.
Thank you.